So we have been looking at how to alter product strength. We've looked at how we can use ratio and proportion. We look at how we can use CSVS, CDVD to alter these product strength that you have. Now let's look at how we can use alligation medial to alter product strength. Now for alligation medial, similarly to the other concepts, you need to understand these different expression of concentrations and what they mean. All right. You need to also understand ratio strength, ratio and proportion as well, and how we use ratio and proportion to respond to the different items that we will see from time to time. Now, as it pertains to the use of alligation medial, we look at this as a method where we can find the weighted average of concentration or percentage strength of a mixture. So you have three products, you have three stock. You know the volume of the stock that you have. You know the concentration of the stock that you have in terms of percentage strength. If it is that we mix all three of them, okay, we can find the weighted average of the concentration for these three different stocks that we mix to give us one. How do we go ahead and do that? We're going to use alligation medial to determine how that is done. So you have the following: 1150 mils of alcohol, 95%, 700 mils of alcohol, 1 in 2, volume in volume, and you have 600 mils of alcohol, 70%, and 50 mils of chlorhexidine gluconate. Now, what is the resulting concentration here? All right. And so there are some key things again that you need to understand. The first thing I'm seeing ratio strength, I'm seeing percentage strength, and then I'm seeing something else as well introduced into the question here. All right. So what does all of this information mean to me? I first need to convert my ratio strength to percentage strength so that everything will look alike, right? And so here, to convert the ratio strength to percentage strength, I already established that one part is in two parts because that is what it tells me here. And if I want to convert that to percentage strength, then I know I need to equate that to 100 parts. So once you calculate that, you're going to get a concentration of 50%, which is in terms of percentage strength. Now we have all of this information here and we need to make sense of it. So you're going to write down what you know. You have alcohol 1150 mils, 95%. That is what you added to the preparation. You added 700 mils of 50% alcohol. You added 600 mils of 70% alcohol. And then there is this thing that you added, chlorhexidine gluconate. It occupies a volume. You added 50 mils of it. But what is the concentration of alcohol in this chlorhexidine gluconate? It didn't tell you that there is any alcohol in it, so you're going to award a concentration of 0 to this chlorhexidine gluconate because there is no alcohol in it. All right. But it occupies a volume, so you still need to consider it in your final preparation. Now you add up all of this, it's going to come up to uh, a final volume of, what is this, 2,500. Okay. Now, when you look at the information that is given to you here, just let me take that back. Just one quick calculation here. Okay, yes. So 2,500, right? Now, when you look at the different concentrations that you have here, you can convert those easily to decimal. All right. So for the 95%, you divide that by 100, you get 0.95, and you do the same thing for the other ones. All right. Now, what are we going to do with this decimal? We're going to use this to multiply the respective volume. So all of these, we converted all of these to decimal. We're now going to multiply them by the respective volume. You multiply them by the respective volume, and that will tell you the amount of pure ingredient that you have in each of those preparation that you added to your mixture. Okay, so your mixture is 2,500 mils in total. Okay, but in terms of the pure ingredient that you added, once you work that out, you're multiplying those by the decimal, you're gonna get 1,092.5 mils of pure alcohol in the 1150 mils. For the 750 mils, it's 50%. You're gonna get 350 mils, and so on and so forth. For yours, 50 mils of pure chlorhexidine gluconate, there's no alcohols, so there's a 0% value here, and so that's 0 mils in terms of pure alcohol as well. Now, you have this information here. We have 2,500 mils of the preparation. So when I mixed everything, it's 2,500 mil. And look at it, you always need to account for all of the volumes, right? Now, in terms of the pure alcohol that we have, we work that out to be 18.62 mils. Now, in terms of concentration, we have two bits of information here that we can go off. All right. So we know that the pure alcohol in the mixture is 1862.5 mils, and the final volume is 2,500 mil. We can simply set up a proportion and determine what the concentration is for the resulting mixture. So we can say if it is that you have this amount of alcohol in the final volume, then you will have X amount in 100 mil, which is what we're going to be using to find the percentage strength. When you work that out, you will get a value of 74.5%. This is alcohol, so we're going to use volume, right? So this is volume in volume. All right. So that's it. You've completely solved the problem to find out what the concentration is of the alcohol in the final mixture. Now, what if you're asked to determine the concentration of the chlorhexidine gluconate in the final mixture? Then you can look at it as, okay, you have 50 mils of chlorhexidine, because remember that's what you added, 50 mils of chlorhexidine gluconate in the 2,500 mil, and this is pure chlorhexidine gluconate. The question did tell you that. So if it is that you have 50 mil in the 2,500 mil, what is this in terms of percentage strength? X mils is going to be contained in 100 mil. Once you work that out, you're going to get 2%, and this you can refer to as weight in volume or volume in volume. All right, so we did 50 mils, so let's put this as concentrate. So volume in volume. All right, now you have another problem here. So for this one, you have some antibiotic. The dose that you're going to be giving, say, for example, to a patient may be a little bit high. And so in this case, we don't want to give just amoxicillin and clavulanic acid alone, which would be the proprietary product augmentin here. You don't want to give all of that clavulanic acid because it might increase diarrhea for the patient. Okay. And so you look at it, okay, I can mix pure amoxil. Now the amoxil is coming from the same manufacturer. The augmentin is coming from the same manufacturer. So I can give some amoxil, which has pure amoxicillin, and then I will give some augmentin, which has the amoxicillin and the clavulanic acid. Okay, and here you will see that written very often where the doctor will prescribe write a prescription for pure amoxicillin, and then they will write a prescription for amoxiclav. All right. So you need to understand what exactly that means. You can either give them to the patient as separate entity or you can mix them together. If you mix them together, you need to make sure that you're mixing similar brands. Okay. And that when you're mixing, you understand exactly what that resulting concentration is going to be at the end, so that when you're writing the labeling information, you're writing the appropriate information for the patient. So I did go ahead and work this out, but I want you to take some time, right? And work through all of these and make sure that the resulting answer that I have here is correct.